Hi everyone, and this is Siva Academy Technical. So today we are going to discuss the first chapter in control systems. So in which we have to know small definitions. That is system. What is system? It is an arrangement or different combination of physical components which are connected such that it gives the proper output for a given input. Okay, that is called as system. For example, the fan without blades. The fan without blades is called as a system. Is it a system? No, it is not a system. Why? Because whenever we switch on the fan, it doesn't give any output. So what is the output of the fan here? Air. So whenever we switch on the fan here, it rotates, and with the help of blades, it can give the output. It can give air as an output. Okay, in this case, in this example, fan without blades is not a system. For example, this is my pen here, so it is also called as a system because of if you write on the body here, so you can able to write the anything on the body here. For example, there is no ink here. There is no ink here, so this pen is not filled with ink. So if you write on the board here, it doesn't give any output, so it is not a system. Means that it gives the a proper output for a given input. That is called as a system. Okay, right. Next one is control system. It is also same, but here it gives the control output for a given input. So we are connecting the different physical components like that here. Then it gives the a proper output for a given input. Same example, the fan with blades and without regulator. Is it a control system? No, the fan with regulators. Fan without regulator is a system. The fan with regulator is a control system. So we can control the output here according to our convenience. If, for example, if it is a winter season, so I can put the position of the regulator at minimum position. If it is a summer, I can put the position of the regulator at a maximum position. Am I correct or not? Yes. So according to our convenience, so we can control the output here. That's why it is called as a control system. In the previous case, so it gives a proper output. So in these two cases here, so both are giving same output. Both are giving us output here. But here, in case of system, it gives a proper output. In case of control system, so which gives the control output. According to our convenience, we can change the output here. That is called as the control systems. I hope that you understood the difference between the system and control systems. Okay, now we can discuss the classification of control systems. After knowing the definition of system and control system, now we are going to discuss the classification of control systems. So basically we have two types. The first one is called as open loop control system. The second one is called as a closed loop control system. Closed loop control system. Now in this class, so we'll discuss the open loop control system. So what do you mean by open loop control system? So basically any control system can be represented by a single block diagram. So this is a single block diagram. So any control system which has input and output. Okay, every control system need input. Because of input, it will give the output. This is the general block diagram of control system. Now coming to the open loop control system. What is open loop control system? Here basically the control system internally can be divided into two sections. The first section is called as a controller. The second section is called as a process. So what is the purpose of controller in control system? The purpose of controller is, so we are giving the input to the controller, so which control the input that is required for the process. And what is the purpose of process here? The purpose of process is it processes the input that is given by the controller, and it processes the input, then it gives the required output. So to get the required output here, so we can control and activating the input signal that is given to the process, that process the input here, and it will give the output. Okay, here listen here. So in this case here, output is not depends on input. Means here the control action is independent of output of the system. That is totally the input is independent of output here. What is that meaning? For example, I can take one example here. That is water heater. Immersion water heater. If you insert the water heater into the water, so it always heats the water. It goes on increasing the temperature of the water because it doesn't have any feedback to tell you when to stopping the heating. What is feedback here? I will tell you later here. That is here, so we have to give the output. Whatever the output we are getting here, that's always which is fed back to the input here. Also, always the input know the output. Always, if the input know the what is output here, so according to the output, the input is controlled. But in this case here, the output is independent of input here. It is independent of input is independent of output. That is the drawback in the open loop control system. So when to stopping the heating, when to stopping heating the water here, we don't know. Manually we can switch off the heater here. That is called as the open loop control system. Okay, next one is here. Next one more example, toaster. So what is the purpose of toaster here? It heats the bread. So whenever we are inserting the bread in the toaster, it will increasing the temperature of the bread. It goes on increasing the temperature of the roaster, and manually we can switch off the toaster. If we are not switch off the roaster after certain temperature, so the bread will heat more. Okay, that means here you are manually switch off the roaster, so there is no feedback that tell you when to stopping the heating of the bread toaster bread. Okay, this is two examples to understanding the open loop control system. One more example is there, that is washing machines and traffic signals. We have so many examples there in our nature. For example, washing machine. So in case of washing machine, so first of all we have to set the time for the washing machine. For example, so I have to wash the clothes up to 30 minutes. That is T equal to 30 minutes. Whenever we switch on the washing machine, so it will apply the controller which give the input depends upon the timing. Up to 30 minutes it will wash the all clothes. Then after that it will be the output automatically turn off. Now I can increase the output here. I can increase the output. Initially I can put only 7 kg of cloths. Now, second case is here I am putting more than 20 kgs. Is it is this time is enough for washing the clothes here? No, definitely we need more than 30 minutes. So that is we are manually controlling the timing of the that washing machine. So this is the best example for the open loop control systems. Okay, traffic signal. Traffic signal is also one of the best example for the open loop control system. Why? So in the traffic signals, all initially we can set the timing 60 minutes, 30 minutes. But according to the density of the traffic, it doesn't control the time here. Density. Okay, now for example, this is the my traffic junction here. So this side here, 30 people are there. This side 30 people are there. This side 60 people are there. But we have to control that signal according to the traffic density. But here initially according to our initial time setting, so it will control the traffic. That is a drawback of traffic signal. So this is one of the example for the open loop control system. Okay, I hope that so you understood these examples. Okay, now coming to the advantages and disadvantages. What is the main advantage of open loop control system? It is very simple in construction and design because it doesn't have any components. Sorry. So it has only less number of components. It has only less number of components. That's why it is very simple in construction. For example, if we have so many components, so many physical components, to connect all the components, it will take more time. It is simple in construction and design also. It will take less time to complete all these physical components that should be connected together. Okay, next here, economy. Because of less number of physical components in the open loop control system, it is economic. Cost is less. Okay, next here, convenient. It is very convenient to use this system when output is difficult to measure it. Where the output is difficult to measure it, so we can use these open loop control systems. Okay, so these are the main advantages of open loop control systems. Okay, next coming to the disadvantages. The main disadvantage is it gives the inaccurate output. Why? Because of there is no feedback in open loop control system. If there is any chances of disturbance which is occurring in the controller, so it doesn't give any desired output. For example, any disturbance, external disturbance, any disturbance which is occurring in the controller, so it doesn't give any output. So we are not eliminating the external errors. For example, so if you ride the bike on the road here, unfortunately there is an accident. Someone came and so he hit your bike, then you slipped on the road. Because of that is the accident is a external disturbance. Okay, so that is called as a disadvantage. So we're not getting the accurate output. So that's why output is inaccurate. Okay, it is not reliable. So it is not a reliable because of that reason here. Because of first disadvantage of open loop control system, it is a not reliable. It's not reliable. So it will not working continuously up to some certain time. Okay, so these are the examples and these are the advantages, disadvantages and applications. Okay, in the next class, so we'll discuss the other type of control system, that is closed loop control system. Thank you very much.